This is probably appropriate in that we're getting started a little bit early because I anticipate some of you are rather interested in this presentation. It's actually a continuation of something the PCARS had going back, I guess, in the 80s and 90s, where we had a fellow by the name of Dennis Decker come in annually in July, I think it was, to give a presentation on behalf of the National Weather Service. At that time, of course, we had fewer cell phones, and the hams or the mobiles were more relevant and more important as far as reporting local weather conditions in neighborhoods. Of course, with the expansion of cell phone service, I mentioned the Weather Service gets quite a few reports from trained observers who are in sky warning but do not have a ham radio ticket. Nonetheless, we still have a good relationship with the Weather Service, and it's our privilege to have Will Ulrich with us tonight.
Thank you, Dennis.
Do
you want to activate the sound?
I think, okay, I will.
Stand by while we do all this technical jargon here. We'll do a sound check. Sound check 1, 2. I'll get a little closer. Sound check 1, 2. Everyone in the back, can you hear me? I'm from Jersey. I talk really loud anyway, so I'll try my best here. I'll also not try to take too much of your time. I know we're here late in the evening, and I appreciate what I really think is an awesome turnout. So thanks everyone for having me. And I do hope that this becomes a future affair that we can continue in future years. Hopefully I have good news every time I come and talk to you guys. I have been in this position as the warning coordination meteorologist. You may have heard of my predecessors, Dennis Decker or Scott Spratt. They were former warning coordination meteorologists since the office opened back in 1989. The office has had a presence here in Melbourne for 30 years, but I am the third WCM here at the National Weather Service office in Melbourne, and I can tell you that I love the area and I have no plans to go anywhere, so hopefully we'll get to work together over the next 10, 20, or 30 years. We have a lot to talk about, and it's all things hurricanes, right? Have you guys had a weather talk in a while? No? All right. It's, always on our mind, right? Hurricanes, tropical systems. And you've probably started to hear them talk about what this season is going to be like, whether it's going to be above normal, below normal, near normal, yada, yada, yada. I'm here to tell you today that at the end of the day, it doesn't really matter how many storms we get in a season, because the fact is, it only takes one. You're going to hear me say that a lot, right? It doesn't matter if it's a below average season. It doesn't matter if above average season. The fact is, we don't know, given the state of the science, where the storms are going to go this early in the season, okay? So the fact is, if we only get one named storm in 2023, which we're not gonna because we've actually already had 3, but that storm happens to cross the state of Florida as a major hurricane, you're all gonna think that, wow, that was a pretty busy season. And yet it was only one named storm, right? It only matters is if those storms impact you. And the fact is, the state of the science tells us we cannot tell you this early in advance where the active portions of the Caribbean and the Atlantic are going to be and whether the threat is higher. Now, don't get me wrong. If we're going to have a busy season, does that mean the United States is likely to be threatened more than, say, a quiet season? Yeah, statistically speaking, if we're in a busy season, an active year, climatologically speaking, the United States does get impacted more. But the fact is, we've had just as many impacts in quiet seasons as we've had in busy seasons. So you can't read too much into that. So here's all the things we're going to talk about today. I want you guys to learn a little bit about the agency that I work for, because the fact is, it sounds like we haven't gotten to interact in a while, so I think it's probably important for you guys to know who I am and who I represent. Then we're going to get all things tropical, all right? So without further ado, a little bit about myself. I love what I do. I have been doing this since 2011 when I graduated from Florida Tech with my master's degree. But for all intents and purposes, I like to think I've been a weatherman since I was 8 years old. Growing up in South Jersey, right outside of Philadelphia, where the March 1993 superstorm went up the East Coast and dumped 12 inches of snow at our house in Cherry Hill, New Jersey. And then just down the road, 25 minutes to the south and east in Atlantic City, We got nothing. We got heavy rain down there, and that's where my family and I were before we decided to go home. And I couldn't get over the fact that you could have no snow at the coast, but somehow get 12 inches just a couple miles up the road. It fascinated me. My mom and dad says that I got interested in weather even before that. They saw me staring up at the sky a lot. At first they were gonna have me tested. Thank God they didn't. They said, oh, this kid's just interested in meteorology. Decided to move out when I was 18 and join Florida Institute of Technology for my bachelor's degree in 2004 and my master's degree in started in 2004, graduated with my bachelor's in 2008, then I started my master's study through 2011. And then I joined the National Weather Service. Again, National Weather Service is a federal government agency made up of 122 forecast offices, like the one on the north side of the Melbourne International Airport. You've probably saw our large radar sitting on a pedestal out there, right? That large radar is what we use to issue all severe thunderstorm warning, tornado warnings that you're used to seeing. But there are 121 other offices just like the one that I work for. Those are considered local weather forecast offices. You can think of us as the experts of the weather in our respective area. We cover East Central Florida, so 10 counties in East Central Florida, from Volusia down to Martin, interior to Okeechobee, Lake, Osceola, and Orange and Seminole counties, and everywhere in between. You just happen to be in the town and the county that the office finds themselves in. There are also national centers across the United States, including the National Hurricane Center in Miami and the Storm Prediction Center in Norman, Oklahoma, ones that you've probably heard of before. But the bread and butter of the operational part of the National Weather Service is those weather forecast offices, of which there are 122 all across the country. This is a look inside of the Melbourne office, and hopefully you guys have probably seen this when you're out and about in town, that large radar sitting on a golf ball. That is the bread and butter of what we do in terms of watch warning advisory issuances. We're staffed with 20 to 25 employees. Right now we're fully staffed actually at 23, but every office is a little bit different, and we are open 24 hours a day, 7 days a week, because we are here for the protection of life and property. That is our ultimate mission, of which we hope to get to a point where society is ready to prepare for and respond to anything that Mother Nature chooses to throw at us. But what do we do as a whole at the National Weather Service? Not only do we issue all those watches and warnings that make your cell phone go off or make you guys activate your local weather net, or when you're watching Tom Terry or Tony Manolfi on television and all of a sudden he interrupts your program for a tornado warning, well, you can blame us for those tornado warnings, because ultimately that information comes from us and on that operations floor that I just showed you at the bottom right image from our office. Consider that when you start to look for weather information online. There are a lot of sources of weather information online. I cannot deny that, Facebook, Twitter included, but also places weather enthusiasts who think they're meteorologists, but they're actually not, like Mike's weather page. There are a lot of pages, websites dedicated to weather that may not be official sources that you may turn to during significant events. But realize 9 times out of 10, the information that they're gleaning from their websites are originating from the National Weather Service. We are a federal government agency. We are paid for by your taxpayer dollars. $7 to $9 of each person in this room goes towards funding our agency at the National Weather Service. So why not get the information directly from the source? Because ultimately that's where your cell phone's getting the information from, and that's where all the local television meteorologists in general get the forecast information from. But in addition to issuing all of those forecasts, we need to understand what the atmosphere is doing right now. And we do that through observation, whether it's through the radar that we have in our parking lot, that large golf ball sitting on a pedestal, whether that's through satellites at 22,600 miles above our head, rotating around Earth, whether it's through buoys out in the Atlantic, or whether it's from our surface observing stations on land right here at the Melbourne Airport and all of our other local airports. We have to understand what's going on now before we even try and tell you what's going to happen 6, 12, 18 hours from now, let alone 3, 4, 5, 6, 7 days from now. We have to know what's going on now before we try and tell you what's going to happen later. In addition to the watch warnings and advisories that you're probably used to getting, like hurricane warnings, tornado watches, severe thunderstorm warnings, things like that, we do issue a myriad of other products like 7-day forecasts, marine, aviation, fire, weather, and decision support products and services. But this is probably what annoys you the most. When your cell phone goes off or your NOAA weather radio goes off. Anyone here have a NOAA weather radio by chance? Couple people? What about whose cell phones have gone off in the past and it says hurricane warning, tornado warning, things like that? I don't care if you have one or the other. I actually encourage you to have more than one way to receive warning information, because it is very important for you to have redundancy when it comes to potentially receiving, say, a tornado warning for your location, or a storm surge warning, or a hurricane warning. What matters is to have multiple ways. That can include television and radio as well. But nonetheless, wireless emergency alerts. I know you guys were probably woken up at 4:45 in the morning a couple of months ago because of a state emergency alert test. Had nothing to do with us, but I can tell you is that if you chose to disable the wireless emergency alerts on your phones after that, you would not get any of the warning messages that you see on the screen here. So I encourage you to make sure you keep that on, because things like tornado warnings, snow squall warnings, tsunami warnings, extreme wind warnings, dust storm warnings are all examples of wireless emergency alert tone activated warnings that come from the National Weather Service. Now, does that mean I'm issuing a snow squall warning? Hell no, I better not be, right? Not here in Florida, but our colleagues up the road may have to issue those potentially life-saving warning information. So, why not get the information from the source? Go to weather.gov.gov, because again, we're federal government, not weather.com or AccuWeather or any of those other sources. Why not get it directly from the source at weather.gov? And you can go directly to our webpage, one of 122 forecast offices, by just going to /MLB. Major League Baseball, Melbourne, whatever you want to do to remember it, weather.gov/MLB will get you directly to the source of the information. All right. That's enough about the agency that I work for. Hopefully I don't have to go through that the next time I meet with you all. We'll talk about all things weather. You're going to hear me use the word tropical cyclone a lot today, and I just want you guys to remember that tropical cyclones is just the generic term for all things tropical, like tropical depressions, tropical storms, and hurricanes. So apologies in advance if I do that, but the technical meteorological term for all things tropical is tropical cyclone. So realize when I say that I may be talking about a hurricane or a tropical storm and things like that. So let's go over some tropical cyclone 101. Nearly 9 out of 10 systems that impact the United States originate as clusters of showers and thunderstorms that move off the west coast of Africa. Those are called African easterly waves. Most of the time you don't hear about them. They just end up dying or dissipating over the Atlantic Ocean. But when they do form, when they do organize around a common area of low pressure, they can potentially be named into a tropical depression, a tropical storm, or a hurricane. As you might imagine, they get stronger from right to left on this screen. So, tropical depression has wind speeds of greater than 34 miles an hour, or up to, 38 miles per hour. Let me correct myself there. Tropical depressions are numbered. 0, or no, it doesn't start with 0. 1, 2, 3, 4, etc. As soon as a system gains wind speeds of greater than 39 miles per hour, it becomes named. We've already had 3 systems this year, A, B, and C. I believe it was Arlene, Brett, and Cindy, correct? Okay. Arlene, Brett, and Cindy. I believe Arlene formed in the Gulf of Mexico and moved south, and then Brett and Cindy moved from the central Atlantic and then just dissipated as they approached the islands. They weren't really that big of a deal. This isn't the time of year when we typically get named systems anyway, right? It's typically quiet in June and July. It's not until August that things really get busy. So we didn't get too worked up over them. Nonetheless, as those systems begin to rotate around a common area of low pressure, as they get stronger and as the wind speeds get stronger, we change their classification as a tropical cyclone. So we start with a tropical depression, and then we move on to a tropical storm, and then we move on to a hurricane. And then hurricanes are ranked from categories 1 through 5. Now, I told you tropical cyclones is the generic definition. Hurricanes is what we call them in and around North America, but they are called different things around the world. Typhoons in the Western Pacific, and then cyclones south of the equator, south of India, and towards Australia. In fact, in Australia, for the longest time, they called them Willy Willies, which I always enjoyed as a kid. Tropical cyclones come in all shapes and sizes, but ultimately they are categorized by their 1-minute average wind speed. So what's the average of the winds over 60 seconds? That's what determines the average wind speed of a system. And so as those winds get stronger and stronger, they go from a tropical depression to a tropical storm to a hurricane, and then once it's named a hurricane, they can be categorized 1 through 5. They become a major hurricane, a category 3 or greater. And I say that top statement there, tropical systems come in all shapes and sizes, because they do. And you shouldn't necessarily correlate the strength of a storm based on their size. In other words, a big system doesn't necessarily imply that it's going to be strong. They can just have widespread showers and thunderstorms around them. Or on the opposite end of the spectrum, don't discount small, compact storms. a la Charlie back in 2004, right? You would have looked on that on satellite and said, wow, that's just a tiny little storm. And yet it ended up having Category 3, Category 4 hurricane conditions in the southwest coast near Punta Gorda. Now, by the time it impacted Brevard County, it was nowhere near Category 3 or Category 4. It was just a Category 1. But realize I hear a lot of people speak here in Brevard County about how they experienced Major Hurricane Francis, Major Hurricane Jean, Major Hurricane Matthew, Major Hurricane Irma, Ian, so on, so on. Brevard County has only ever experienced truly, I'd say, up to Category 1 hurricane conditions. We have not experienced a major landfalling hurricane system. That's not to say it can't happen, because one day it will. I hope I'm not here for that, because I can tell you our infrastructure, quite a bit of it in this county, is not prepared for a Category 3 landfalling system. But when that day comes, we'll be here to respond to it like every other storm system. Because hurricanes, again, are ranked from Categories 1 through 5 once you get wind speeds in excess of 74 miles per hour. In general, we go back to Hurricane Matthew in 2016. We saw a small sliver of the Brevard County coastline that experienced Category 1 hurricane conditions. I believe during Hurricanes Francis and Jean, our barrier island communities, and if you lived east of US 1, you probably saw Category 1 hurricane-like conditions. But in general, every other system that has impacted Florida, even if it's a Category 3 or 4, has only been a tropical storm or a minimal hurricane, Category 1, by the time it impacts our area. So we have not survived collectively in this room a major landfalling hurricane. Now, if you consider yourself a Floridian, yes, we have survived a major hurricane like Ian, Irma, etc. But locally here, we have not had to deal with that before. And I hope we don't, okay? Why? Because of this right here. It's not that a Category 2 hurricane is twice as strong as a Category 1, or a Category 3 is 3 times as strong as a Category 1. As wind increases, its potential for damage exponentially grows, such that a Category 2 hurricane is 10 times capable of producing damage as a Category 1. A Category 3 is 50 times as potentially damaging as a Category 1 hurricane. And God forbid you're ever impacted by a Category 4 or Category 5 hurricane. While major hurricanes only account for about 1 in 5 landfalls in the United States, they account for about 80 to 85% of all damage statistics in the country. Now, you know, we've had to deal with our fair share of hurricanes in Brevard County, and we've been threatened by each of the things that you see here on the screen, whether it's damaging winds, heavy freshwater rainfall flooding, storm surge, and tornadoes. Though, all things considered, the amount of storm surge that we've received on this side of the coast has been fairly minimal. Okay, we're not as susceptible to storm surge here in Brevard County as other portions of the Florida coastline are, like Southwest Florida, and that has to do with the bathymetry or the shape of the coastline and how the sand slopes as you go deeper into the water. It would take a Category 2 or Category 3 landfalling system to really pose a threat to our barrier islands. Again, I hope we don't experience that. But what matters to you out here is that if you are in a storm surge evacuation zone and they call for an evacuation, please evacuate. Why? Because storm surge, without a doubt, has the highest potential of loss of life compared to everything else that you see on that screen. Why? Because you're literally talking about the ocean rising and pushing on shore. And then the strong winds are building up the waves on top of the ocean, and now you have waves impacting your home. That's a lot different than, say, freshwater rainfall flooding, where the rain falls out of the sky and water slowly but surely creeps up into your home. That's not the same as the ocean or the river pushing on shore and potentially impacting your home. Do not mess with water, particularly storm surge. We say, run from the water, hide from the wind. Do not mess with storm surge. When we look at an average Atlantic hurricane season, this is what it looks like. From June 1st through November 30th, that's the average season. About 98% of all tropical systems occur within that window, 97%. Things really get busy when we get to August, right? You see how things ramp up. Red being tropical storms and hurricanes, yellow being just hurricanes. Things really ramp up in August. In fact, after August 1st, about 80% of all tropical cyclones occur. So typically, things really don't get busy until we get into August. How can I show that visually? by showing you hurricanes that have passed within 150 miles of that blue point. That blue point is somewhere near the Polk County, Osceola County line. And I drew a dotted line, 150-mile radius to the east and to the west and to the north and to the south of that blue dot to show you storms that have passed within 150 miles. Why? Because hurricanes are not points, right? They're large systems that have impacts that extend hundreds of miles from the center. Generally, the worst impacts are within very close to the eye of the hurricane, but significant impacts can occur up to 100 to 200 miles from the center. So what I wanted to do is I wanted to visually show you every hurricane that's passed within 150 miles of that point. And in the month of June, going back to 1851, this is what it looks like. Only 2 hurricanes have passed within 150 miles. There are some that get very close, and they show the lines on this map here. But only 2 have actually passed within 150 miles. In the month of June, over a 170-year period. Look at July. July is just as quiet. I'm not here to tell you that we're not going to be impacted by a hurricane one year in June or July, because the fact is, we may be. But the odds, the statistics tell us that it's pretty rare. But then that all changes in August. Okay? It jumps from 5 to 22. And you notice a little bit more color on the screen as well, because they're getting stronger. Category 3, 4, and 5 hurricanes. It doesn't get any better in September, which is, statistically speaking, the climatological peak of the Atlantic hurricane season. So of course we're going to be impacted more by systems in September. But a little known fact, people think that the threat of hurricanes in Florida drops in October. Would you believe we've had more systems that have moved within 150 miles of Florida in October than any other month? October, we've had 34 hurricanes within 150 miles of that point. September, 27. August, 22. So believe it or not, October is the busiest. But I would argue from a threat perspective, September is actually the highest because it has the most number of Category 3, 4, and 5 hurricanes impacting the state. That's not to say we haven't had major hurricanes in October, though, either, because you do see some purple on the map. In fact, I can look back to Matthew in 2017. That was a Category 3 hurricane just off our coast. We got incredibly lucky that the eye of that system did not move on shore. And then Hurricane Wilma was a Category 3 when it made landfall in southwest Florida and rapidly moved across the state. Portions of the Treasure Coast saw Category 1 to Category 2 hurricane conditions down there in that year, back in 2005. And then there's November. Everything shuts down in November. Unless your name's Nicole, who decided to visit us last year. As a Category 1 hurricane near Vero Beach decided to ruin my birthday. Normally I don't talk about hurricanes in early November, but being that my birthday was November 8th, Mother Nature decided to say, screw you, Will. So, some of the products and services available to you all from the National Weather Service and the National Hurricane Center. Remember, when I say National Hurricane Center, that's our national centers. They're the ones that are responsible for charting all of these storms that I tell you. It's not my job to worry about whether there's a hurricane out in the Atlantic until it looks like it's going to potentially impact us. Otherwise, it's the National Hurricane Center that draws up those 5-day charts, or those wind speed probabilities, or those forecasts that you see when you turn on the television, or when you go to Mike's weather page. Storm Prediction Center, Weather Prediction Center are all examples of National Center product information. And when you're further and further out from a system, unfortunately, there's less and less information, right? Because the fact is, uncertainty is at its highest when you're 5, 6, 7 days out from a storm. But what I can tell you is there are some products that you can glean some information from, including the Tropical Weather Outlook at days 6 through 7. The 5-day forecast cone doesn't get activated until there's actually a named system. Then when you're within 48 hours, we might hoist tropical storm or hurricane watches and warnings. Maybe storm surge watches and warnings for those of you that live east of generally US 1. And then on impact day, when everyone should be taking cover anyway, we might have to issue warnings of last resort, like tornado warnings, extreme wind warnings, flash flood warnings. At that point, hopefully you guys are in for the day when the storm is impacting you, taking a break, breathing, and then all of a sudden you get a message that says, oh, a flash flood warning is in effect for my location, or tornado warning. Maybe I need to shelter within my shelter. We call those warnings of last resort to ensure that everyone gets to their safest place during a particularly, high threat. So that 7-day tropical weather outlook that I mentioned is issued by the National Hurricane Center whenever there is a disturbance out in the Atlantic or the Caribbean. And that X marks the spot of where the system is, and then the hatched area represents where it may develop over the next 7 days. It is not yet developed. It is basically a cluster of showers and thunderstorms that may or may not have moved off of Africa, might have originated in some other form, but that system may or may not develop somewhere within that hatched area. Don't use it as a track forecast, even though you can insinuate where the general trend of the system is expected to go. This only is meant to tell you where the system is going to develop, because once it develops, that's what this is for, the infamous 5-day potential track forecast. You may hear it as the cone of uncertainty. I hate using the word uncertainty because the fact is that makes it sound like they don't know what they're doing. And the fact is the state of the science has gotten a lot better through the years. Why do I know that? Because of the size of that cone has about halved since its inception back in 2003. These are the statistics to show that. Back in 2003, the average error at 1, 2, 3, 4, and 5 day out, red is 1 day out, green is 2, 3, 4, and 5, so on. The average error has about halved. So back in 2003, the 5-day error was 500 miles. In other words, we couldn't tell you where the system was going somewhere between here and North Carolina at 5 days out. Now it's dropped to about 250 miles. That's still pretty big though, if you think about it. From north to south, Florida, right? If we think 250 miles, it's probably from Jacksonville to Fort Pierce, something like that, or Miami to, what's exit 250? Daytona? So at 5 days out, we're still not able to exactly tell you where it's going to make landfall in the state of Florida. And I'd argue that it's even a little bit more difficult than that. What I want you to pay attention to is the red line. 5 days out, we couldn't tell you where the system's expected to go within 1 day. I just said 5 days, I apologize. 1 day out, 24 hours out. Back in 2003, the average error was 100 miles. That's basically Melbourne to Tampa-ish, 80 or 90 miles, give or take, a little bit bigger. That number has dropped to about 45 miles. That's still from here to the outskirts of Orlando at 24 hours out. So tomorrow, if we had a landfalling hurricane tomorrow at about 7 p.m., I wouldn't be able to tell you where the center of the system is expected to go between here and somewhere in Orlando. We still have a long way to go, is what I'm telling you. And small wobbles in the track, particularly when the system is further away, have huge impacts on what's going to happen at day 2, 3, 4, and 5. This 5-day cone is meant to tell you where the center of the system is expected to go. The center. But I just got done telling you that hurricanes are very large, right? They expand outwards hundreds of miles. So the fact is, it doesn't matter if you fall in or out of this cone. You could still be potentially impacted. And a good way of showing that is from Ian back in September. This is advisory number 19 when it was just west of Key West. Notice how much area is covered in tropical storm and hurricane force wind warnings, yet they're not in the cone. Because this cone, again, is only meant to tell you where the center of the system is expected to go. It doesn't tell you anything about impacts. So please keep that in mind. And part of the reason why we're not able to tell you exactly where it's going to go is because Mother Nature, first and foremost, is going to do her thing. You know, as much as we try and forecast her, she's still going to go, aha, I've got you. The fact is, the modeling, the science still isn't there to be able to resolve the inner workings of a hurricane, to understand how it interacts with the broader atmospheric pattern. So we're not to the point yet where we can tell you exactly where these storm systems are going to go. And look at how large these errors are. 45, 90, up to 150, up to 200 to 250 miles out as you get further and further away from the system. So please keep in mind that just because you may or may not fall inside of that track doesn't mean the threat at your location is zero. Use that as a means to tell you, hey, I need to really pay attention to this storm, and what does it mean for me? What type of impacts can we be looking at? Because we had to deal with not one, but 2 storms last year. And if you remember correctly, we all forget about it, we actually had a 3rd storm in the month of June of last year. Potential tropical cyclone number 1, Alex, impacted us and dumped a lot of rain. We ultimately didn't see any tropical storm conditions here, but nonetheless, we did have a 3rd system that impacted us. But overall, Ian trumped everything. From a 2022 hurricane season perspective, by the numbers, it was an average season. On an average season, we would expect 14 storms, 7 hurricanes, and 3 major hurricanes. What did we actually get? We got 14 storms, 8 hurricanes, and 2 major hurricanes. So by the numbers, last year was an average season. But if you're a Floridian, like we all are in this room, would you consider last year a quiet or an average season? Absolutely not, because Ian devastated the state, and then Nicole devastated the coastline from Cape Canaveral northward. So from a cost and impacts perspective, last year will be looked at as one of the worst years on record. It will be the costliest hurricane season on record and the 9th deadliest for the state of Florida. Because we had 3 storms. Alex back in June of last year, Ian in September, and then Nicole the second week in November. Ian's going to be remembered for its rainfall flooding. In Brevard County, we got between 4 and 7 inches south of Rockledge, and then north of Rockledge, 8 to 15 inches. Mims and Scottsmore actually saw some pretty significant flooding due to 15 to 17 inches of rain up in that neck of the woods. But the bullseye, unfortunately, was Seminole County and Volusia County that got upwards of 20 inches of rain. Ian's going to be remembered as a water storm, not just from the rainfall perspective here locally, but from the devastating damage that occurred across the southwestern coast of the state, where storm surge led to the most prolific damage of all that damage that you saw in the southwestern portion of the state. Ian's going to be remembered for its storm surge and rainfall flooding. Why? Because overall, the building codes in the southwest portion of the state, when it comes to wind speeds, are some of the highest in the state. So we didn't see a lot of significant wind damage. The majority of the damage that we saw was from storm surge. That's not to say homes weren't damaged by the wind, because of course they were. That's what happens when you get wind speeds of 140 to 150 miles per hour. But the fact is, some of the best building codes are located along our southern portions of the state. So they were able to withstand that a little bit more than, say, a Category 3, Category 4 hurricane impacting locations a little bit further to the north. Wind speeds here locally were on average strong tropical storm force with wind gusts up to Category 1 strength. We saw between 65 and 75 miles per hour in Ian of last year. A quick note, freshwater rainfall flooding is not related to the intensity of the storm, but the speed. What do I mean by that? Even tropical depressions and tropical storms can produce prolific flooding here. Who was here in 2008 for Faye? Quite a bit of you. Faye was quote-unquote just a tropical storm, and yet there was a site off of Wickham that recorded 28 inches of rain. More than what we saw anywhere in Ian. 28 inches of rain in Melbourne will do a number on you. I'll never forget driving down 192, and almost all of 192 was underwater.
They moved the firehouse on Patrick because of that.
Yeah.
The firemen woke up and they stepped out of their beds in the water.
Yeah, that's kind of the penultimate storm system for Brevard County. Yet it was just a tropical storm. But people probably woke up that day saying to themselves, oh, this thing's just a 35 to 45 mile per hour hurricane. I don't have to worry about it. And yet we were playing up the fact that this was going to be a prolific rainfall. Stop focusing on the category. Stop focusing on the name. Look at it from an impacts perspective. That's the best thing I can tell you. Hurricane Nicole in general, of course, weaker overall. Rainfall amounts in general were 3 to 7 inches across the same areas that got the heaviest rain in Ian, amazingly. And then locally, wind speeds were between 35 and 55 miles per hour. But it will be remembered for the devastating damage that occurred along the Volusia County coastline, where a lot of homes and businesses kind of were condemned or collapsed directly into the Atlantic Ocean. Now, I told you that when it comes to tropical rainfall flooding, the category simply doesn't matter, because it doesn't. Back in 2008, Faye, you see the track. Each individual black line that you see is the track of the center of the system. So back in 2008, Faye moved up from the southwest Florida coast, went over Melbourne here, and the heaviest rain fell right along the track of the storm. In Irma, the heaviest rain fell to the east of the storm. And then in Ian, the heaviest rain fell to the north of the storm. So it doesn't matter what side of the system you're on either. the heavy rainfall threat can materialize on any side of a tropical storm, and we won't necessarily know that until a couple days in advance of the system. So not only does it not matter what the system is classified as, whether it's a tropical storm or a hurricane, we're not also going to be able to tell you exactly where the heaviest rainfall is going to set up until a couple days in advance of the system. And why is that important? Look at Ian. The heaviest rain fell directly to the north of the track. But when you think about the potential track of the storm, a couple days out, the landfall of the system could have been all the way up in Tampa, or it could have been even further south of Fort Myers. And so that rainfall band also shifts with the track. So that's why there's so much uncertainty when it comes to tropical cyclones. So when we look back at 2022, even though it was a near average season, it's going to go down as the costliest in Florida's history and the 9th deadliest season on record. Also, if you don't remember, guys, but last year at this time, everybody was commenting about how busy of a season it was going to be because we got the A, B, and the C storm last year, the Alex, Bonnie, and Colin storms in June of last year. And everybody went, holy crap, 3 named storms in the month of June. This is bound to be a busy season. And then suddenly Mother Nature said, never mind. And we didn't get a single storm for 60 days. And most of July and August was quiet. So we got a lull. And you know what the same people that were saying about how busy the season was going to be were saying during that 60-day period? They suddenly were singing a different tune and saying, oh my God, this is going to be the quietest season on record. I can't believe there hasn't been a named storm in 45 days, 50 days, 55 days. Fact is, you cannot use early season trends as an indicator for what's going to happen later in the season. Because as I showed you with those charts earlier, statistically speaking, not a lot of storms happen in June or July. So the fact is, it just doesn't matter what happens in June or July as it relates to later in the season. In fact, I've been hearing the same things this year. We had the A, B, and C storm just a couple of weeks ago, right? So everybody's talking about how busy of a season is going to be. There are some signs that point to maybe this is going to be a busy season, but there are just as many signs that are saying the exact opposite. So please, at the end of the day, does it really matter? No. Let me take it one step further. 1992, Hurricane Andrew, the A storm, the first storm of the season, waited until August 12th or 13th, somewhere towards the middle of the month. I don't remember the exact date, to make landfall in South Florida as a Category 5 hurricane. Would you believe it was one of only 7 named storms that year? We only got 7 storms back in 1992, when typically we would get somewhere between 12 and 13. Now on average, we get about 14 named storms per year. So in 1992, we had about half of what we would typically expect, and yet South Florida was hit by a Category 5 hurricane. So the fact is, it doesn't matter, again, how busy or not a season is. And stop trying to read into early season trends. This year, here's what we're looking at. And then I think it's time for me to take some questions. Yep. All right. In 2023, we've got a couple factors that are going to add to uncertainty this year. But they matter. Because not only is it going to impact summer, it's going to impact us later this year in the winter and spring. For the past 3 years, this is what the water temperatures have looked like in the Pacific Ocean. That was from November of last year. It's fluctuated somewhere between 2 to 3 degrees below normal, 2 to 3 degrees centigrade below normal. This is indicative of what we call La Nina conditions. La Nina are when water temperatures in the equatorial Pacific, the waters of the Pacific near the equator, are below normal. That bottom chart is what they look like now. They have warmed significantly. They've warmed 5 to 6 degrees Celsius. Now those same waters that were several degrees below normal are now much above normal. And they've only gotten warmer. That chart's actually from 2 months ago, back in mid-May. It's now even warmer. What that tells us is we're seeing an El Nino develop. It's already developed. That chart, that bullet point is actually old. Shouldn't say likely, it has developed. El Nino typically reduces the number of hurricanes that we see in the Atlantic. Why? Because you see, thanks to this warmer than usual water, you see more hurricanes and tropical storms in this part of the world, so that naturally offsets what we see in the Atlantic, because it increases wind shear in our neck of the woods, and hurricanes don't like wind shear. So when you get more storms in the Pacific, generally the Atlantic quiets down. That's typically. Unfortunately, this year is not a typical year because of this right here. This is what water temperatures are in the Atlantic Ocean right now. And I have to say, not right now, 2 months ago. This is 16 May. This is what water temperatures look like in the Atlantic and the Caribbean. What are you noticing a lot of? A lot of yellow and oranges. Temperatures are several degrees above where they should be for this time of year. And if I were to show you a chart, I happened to just look at it before I left the office, but I didn't update the chart. There's almost no blue anywhere on the map anymore, and now we're starting to see some reds. For some reason this year, the Atlantic is on fire, and it has baffled all meteorologists. I cannot explain it. There's some theories out there, but man, oh man, the Atlantic is warm right now. It's warmest it's ever been, by far, since record keeping began. And the fact is, hurricanes like warm water, right? That's their feeding mechanism. So this may counterbalance what El Nino is expected to do this year, and we could see more storms than we would otherwise expect during an El Nino summer. I say all this to say this right here. The fact is, the odds of an above normal, below normal, and near normal season are pretty normal, or are pretty averaged across the 2023 Atlantic hurricane season outlook. The fact is, there's so much uncertainty, forecasters really weren't able to commit one way or the other. I would argue, based off of what we're seeing this year, that it's probably going to be near to maybe slightly above, but we'll see. Does that matter to anyone in this room? Is anyone planning for FEMA at the federal level? Is anyone own a local insurance company who might be able to make some adjustments based off of a Atlantic hurricane season forecast? No. On an individual basis, we need to be prepared regardless of what Mother Nature chooses to throw at us this year. Because it could be the quietest season on record, it could be the busiest season on record, and we could still potentially be impacted by a hurricane locally. I told you earlier that an average hurricane season looks like this on the right, 14, 7, and 3. This is the forecast, somewhere between 12 and 17, 5 and 9, 1 and 4. What that tells me is that we really, unfortunately, don't know because of the competing factors like El Nino, which would tell us lower than normal, and then the Atlantic, which is on fire for some reason right now, and that would tell us, oh, no, you're going to get more storms this year. We just don't know at this stage of the game. So with that said, use seasonal tropical forecasts as a reminder to have your hurricane preparedness plan in place before the start of the hurricane season. Right now, the forecast is for a near average season, but I saw that the Colorado State University, Dr. William Gray, Dr. Phillips Klotzbach just updated their forecast last week from a near normal season. They're now calling for an above normal season. The fact is, I've told you this time and time again, we look back to 1992, 1985 at pretty quiet seasons where the United States still gets hit by a hurricane. So the fact is, it only takes one, and you guys should be prepared regardless of what I say to you every year at this point, assuming y'all invite me back next year. That's all I got, guys. Thanks. I do think we have some time. So, I got any questions? Yeah.
2 questions.
Okay.
Is it just my perception, or is the northeastern quadrant the most dangerous quadrant?
Yeah. Yep.
Can you explain why
Sure.
in a rotating hurricane the northeast section would contain that characteristic?
Sure. You're not wrong. The eastern semicircle of a hurricane is statistically the strongest. Oh, there we go. I can show you this right here. All right. Oh, is it going to come back? I think I might have disconnected it too. If not, I'll just have to do it with my hands. All right. There is a reason that hurricanes have their most prolific impact on the northeast side of the storm for 2 reasons. First, it's where wind shear is maximized due to the hurricane, not wind shear in the overall atmosphere, because I told you hurricanes don't like wind shear, right? But hurricanes produce their own wind shear because they change the wind direction with height as you go higher in the atmosphere. So the most common location for tornadoes are in the northeastern section of a storm. The strongest winds and the heaviest rain occurs in the eastern side of the storm because you have to add the forward motion of the storm to the wind speeds of the hurricane. So, because storms spin counterclockwise in the northern hemisphere, when a storm is moving to the west, which generally they do, to the north and west, you have to add its forward speed and whatever the wind speed that the hurricane is producing together to get the impacts. So that's why your strongest winds are here and your lowest wind speeds are here. That's not to say, I say strongest and lowest, right? That's not to say they're not significant, because you can still have a major hurricane that has major hurricane force winds on the bottom here, but where you add the forward motion of the storm on the northeastern side, you subtract it on the southwestern quadrant of the storm. So it has to do with the forward momentum, the forward motion of the storm. And that quadrant can change based off of the motion of the storm. If the storm's moving directly west, the worst place to be is in the northeastern quadrant. If it's moving to the north, it's actually towards the eastern half of the quadrant, still, which encompasses part of the northern part of the storm. So it all depends the exact direction of the storm as well. But you're adding the forward motion to that side of the storm in the northern hemisphere. It's the exact opposite in the southern hemisphere.
And what is the rating of your golf ball?
Category, oh geez, I think 125, so that'd be category 3. Yeah, category 3. We wouldn't expect it to make it in a category 4 hurricane. And we looked to Hurricane Maria in Puerto Rico a couple years ago. They lost their radar because they were category 4 conditions. And Lake Charles in, what storm impacted Louisiana? It wasn't Katrina, this was just a couple of years ago. They lost their radome, the covering, the radome. It didn't tip over. It's actually a PVC covering, so that's what's failing, not the radar itself. That was like category 3. So somewhere around 115, 125. We would lose it if we had a major hurricane move directly over Melbourne, but we would utilize Tampa, Jacksonville, and Miami when our radar goes down. We have redundancy.
Did they beef up Miami's for a category 5?
They did, yes. Yeah, they have a little bit better wind rating down there. And they did in Puerto Rico too, but it still failed, so.
Yes, you have mentioned the impact being the most important factor.
Okay.
Is there some way that you can give a number relative to the impact, like category 4 with impact of? Can you give a number to give us some feeling of that?
Yeah, I would say that we are, what happens a lot of the times is when we say the category, right? People say category 2, oh, that's not a major hurricane, I'm gonna stay. And then that category 2 storm ends up having wind speeds, wind gusts of 115 to 125, which is category 3, right? We're trying to steer away from that and speak more to impacts by saying major hurricane force winds of 115 to 125 miles per hour. There's a whole facet of meteorology, social science, that is trying to determine the best way to communicate impacts. And that starts with us, who then communicate with emergency managers and the media, who then pass that information to you all. I would say that we're in a bit of an infancy period when it comes to that new type of messaging. We're not there yet, but we're trying to get better at it. And I would like you guys all to think more from a impacts perspective versus a number. We're gonna continue to tell you what the maximum potential wind speeds are. We're gonna tell you 100 to 115 miles per hour, but we will start corresponding impacts to that. Mobile homes will be lifted off their foundations or destroyed. Single family homes will likely lose their roofs. Things like that that would get you to go, would I want to stay in my mobile home? Would I want to stay in my single family home for that type of storm? That's where we're trying to go. But you all know just as well as I do that homes come in all shapes and sizes. So to be able to speak to all of them and their potential impact is going to be very hard. And I just don't know what the answer is yet. But if we could get away from categories, you know, use categories as a means to maybe say, hey, how significant of a storm this really is, but then look to impacts to make your decisions. I don't know the answer to that just yet. Yeah.
With all due respect, when I'm seeing things on TV during an active hurricane that they're tracking, you see the European models,
Sure,
and the U.S. models, and so forth, and it appears to me more often than not the European models are more accurate. Why is that? Because they don't have hurricanes. We
yeah,
do.
the irony of it all. It's a competition. Let me put it this way. The American model and the European model, no doubt, are the best models. They're the ones that you focus on the most, right? Because they're the ones that get all the airtime. The European and the GFS. There's a reason that you hear about them the most. One, why? Because one's American made, one's European made. European is also a collective of how many countries bringing together their best, scientists to understand the atmosphere. It is a constant struggle back and forth. One year the American model will do better here. The Europeans will correct it so that they get better than the GFS did on, say, temperatures. Then the GFS or the European will do better on, let's say, hurricane tracks. Well, then the scientists at the GFS model will augment their model to make it better than the European the next year. And so it flip-flops from year to year. Competition's great. That's how it should work. But in general, the best performing model, without a doubt, is an ensemble. And an ensemble is just a concoction of multiple models put together that include not just the GFS and the European model, but also differing runs of those same exact models. So we initialize the GFS 30 different ways. We start the European model 30 different ways. Maybe we change the shape of the storm. Maybe we make it a little bigger. Maybe we make it a little smaller. Because do we know exactly what the hurricane's doing at every single moment? No. So we change a little bit by running the model multiple times and seeing what happens to the track. So the best overall model collectively are those ensemble models that the National Hurricane Center uses. And I'll take it a step further. The National Hurricane Center track forecast blows all other models out of the water. So while you see the GFS and the European competing against one another, that 5-day cone that I showed you outperforms both of those models collectively. So keep that in mind. I know you guys are going to love looking at the GFS this year and you're going to love looking at the European, but the fact is, collectively speaking, the National Hurricane Center forecast is still the best. One more point about what you just mentioned. The European is better at certain things, but so is the GFS. The GFS is better at local wind speeds and local precipitation distribution, so where the thunderstorm is going to develop. They're still not great, but it's better than. The European tends to be better in other ways. They each have their strengths and weaknesses. But when it matters, when you're paying attention the most, is when there's a hurricane. And so that's what you focus on. And so the best thing I could tell you is year to year, the European and the GFS kind of fight for that best spot in hurricane forecasting. Try not to focus that on so much. Try to just focus on the National Hurricane Center.
So I understand there's plenty of different hazards associated with hurricanes, and typically we all focus on the wind speed. Understand that it could be a whole bunch of other factors, but typically when hurricanes make landfall, they lose that wind speed fairly rapidly.
Yep.
Understanding that this is just a typical and not a hard and fast rule, is there a general guideline of how far inland you would want to be from a major hurricane or hurricane making landfall to get to, say, again, hurricane.
All right, I know what you're doing. I know where you're going. So I can always tell you that Orlando is going to be better in a landfalling system regardless of whether it's coming from the west or the east, right? The further inland from the coast you are, the storm has time to spin down. But here's the problem why I caution saying that to you all. because you have a lot of land between here and Fort Myers. So part of the reason why I say that you guys have never experienced a major hurricane here is because we had all of Florida to help weaken those systems before they got here. But they were still impactful, right? When you think about Irma, do you remember all the tornadoes we got? The very strong winds that we got in Irma back in 2017? And then Ian, we got a prolific amount of rainfall flooding. But did we, quote unquote, dodge the proverbial bullet in those storms? Yeah, for the most part, because those storm systems were slow-moving major hurricanes when they made landfall in the southwest coast, so they had time to spin down. My biggest concern is a rapidly moving major hurricane, a la Wilma back in 2005, that was still a Category 2 hurricane when it reached the other side of the coast. When it went over West Palm Beach, it had wind speeds of over 100 miles per hour. So I can't tell you with confidence that is there X number of miles that you want to be inland from a storm moving from the west and the east. There's no doubt in my mind that you need to get away from the coastline in most scenarios, because the strongest winds are going to be over the Barrier Islands and along and east of probably US 1, in some situations along and east of 95. But there will be some storms that maybe come straight up the coast. There, God forbid, Matthew had been 30 miles to the west of where it actually was, because we would all still be cleaning up here. That was a major Category 3 hurricane that could have raked the entire East Coast if it had just come a little further west, but it didn't. It wouldn't have mattered how far inland you were. Though, I would say that the lesser winds would have occurred west of 95 and then progressively gotten stronger. But everyone still would have potentially saw major hurricane winds. My biggest fear is a Dorian that doesn't actually turn, right? And you do get that Category 3, Category 4 hurricane from the east. That would be the worst case scenario for us here in Brevard County. What are the odds of that? They're incredibly low. So let's hope we never have to experience that. But I don't think there's a hard and fast answer to you. And one more. Hurricane Michael up in the Panhandle stayed a major hurricane all the way into southwestern Georgia. And so the fact is, it was able to maintain its structure because it moved so quickly and was so strong at landfall. It was a Category 5 hurricane. If it can happen in the Panhandle, it can happen in South Florida. And I would argue that South Florida, because of its swamps and warm water temperatures, Michael wouldn't weaken as fast if you had put Michael coming up, the spine of the peninsula. So in general, the strongest winds will always be the closer you are to water, but there will be scenarios where our entire community is threatened. That's the best way I can put it.
Dan, you got one more question? You.
Well, we hear, and if you look statistically, it's rare for a hurricane to hit our area directly. Not saying it hasn't happened, but statistically it's rare. Is there a reason that people have said, well, it's because of the shape of the state, it's because of whatever, but there must be some reason why.
No, it has nothing to do with KSC. I just heard that. KSC didn't put it here because, now they may have studied, no, they didn't. They put it back in the 1950s. We didn't have hurricane climatology back in the 1950s. They chose that because it stuck out into the Atlantic and rockets would fall down into the Atlantic Ocean. That's why they chose Cape Canaveral. Part of it is this angle that you see right here, okay? The shape of the coastline is like this. So it stretches from the southeast to the north and west. And then you get this little, it's hard to see on this map, you get this little concave shape north of Cape Canaveral. It is hard to get hurricanes that move up into the north and west to suddenly hook to the left and make landfall in our locations. So part of it is this orientation of the coastline. Now, one of the reasons why is because of the placement of the Bermuda High. The placement of the Bermuda High, which is kind of a permanent area of high pressure near Bermuda, it's ultimately what pushes storms in the direction of Florida. But depending on its exact placement, it shifts a little east, it shifts a little west. That changes the tracks of the hurricanes. You can still get major landfalling hurricanes south of Melbourne because, why? Florida kind of juts out, it kind of sticks out. But once you get north of about Vero Beach, the coast takes on a bit of a concave shape, and its orientation is generally in the direction that storms move by the time it gets to our latitude. So it's hard for those storms to hook left because the same system that is moving the storm to the north and west generally doesn't suddenly build back and push that hurricane towards the coastline. I can tell you that there are records from the 1800s that suggest we did have multiple landfalling major hurricanes close to Melbourne. Ship records and indigenous people who used to live here tell us that there were major hurricanes that have impacted the area. Now, how reliable are they? I don't know. We don't have direct observations, right? We just have stories. So I don't think we'll ever know. But it would be silly for us to assume that we're not susceptible to at least a Category 3 hurricane. And I think to an extent, Hurricane Matthew got us thinking about, oh damn, we came pretty close to disaster here. But you are not wrong in your assessment. Statistically speaking, it is rare to get major landfalling hurricanes north of Vero Beach. You're not wrong. And I hope that stays the same. But I can't promise that it will. I can't promise that it will. I think we have to end it there?
I think we're gonna.
Okay.
We're gonna take it here. Great presentation.
I'll be back again, hopefully.
You will actually definitely be back next year because this is very good for the club to get prepared for hurricane season. It opens up everybody's eyes. You know, we're all doing Skywarn and things like that, so you will be by Joe Derek.
Thank you. One thing I want to mention, who here is a Skywarn spotter for us? Please talk to those folks after today, and if you guys have interests, I'd be happy to host a Skywarn training session so that you all become certified storm spotters for the National Weather Service. I basically teach you how to identify severe weather, characteristics, and what's severe weather, what's not severe weather, and you report that information to us at the National Weather Service that we use to issue tornado warnings, severe thunderstorm warnings, things like that. So I'll work with you, Dennis, at some point, if you guys would like. That's a 2-hour class, so we would need to augment your meeting and be prepared for it to be a little longer.
Actually, a lot of us have been to the one that Derek had taught here a couple of years ago at the Weather Service.
And yeah, sometimes we open our office to it, so if but if you want to all do it as part of your meeting, we can do that too. Or maybe we set up a separate meeting. Whatever you guys want to do.
Okay,